All right, so I finished my general announcements. That included reminding students once again, we have a homework every single day this week. We have a CFU this Thursday as well as a CFU next week, Tuesday. And then we have a test on Friday next week. And as always, that test will not be reassessable. It's a one and done. Okay. Students were already given time to complete the multiplication at the top of page 26. And as I explained already to the students, we have 3 practice problems, but we should be able to finish early enough that you get some time to work on homework 26. So let's get right into it. It says, at the beginning of a study, there were 250 bacteria. 4 hours later, there were 610 bacteria. Use the formula to answer the questions below. Now, the initial reaction when I'm asked compute the growth rate of that bacteria, what I'm realizing when I read that is that was not given. They didn't give you the growth rate. We have to do a little bit of work to figure it out. Now, what they did tell us is that in the beginning, there were 250 bacteria. And 4 hours later, there were 610 bacteria. That, believe it or not, is every number you need in that formula except for R. Okay, so just to go through it real quick, that tells me my initial value was 250. That tells me after 4 hours, the final amount of bacteria was 610. So I literally know every single value in that formula except for R, which is why part A is figure out the growth rate. In other words, figure out R. Okay, so writing this out, I know we started with 250 bacteria. I don't know what the growth rate was, but I know after 4 hours, we ended with 610 bacteria. That is step 1. Set up a formula that allows you to solve for the one thing you don't know. Now, on your CFU this Thursday, if that's the only thing you're able to do, that's going to earn you credit. Okay, that's a way of showing some work. Now, can anyone suggest a first step for solving here? Yes. Divide both sides by 250. The whole idea is we need to get the R by itself. So we got to get rid of that 1, but we can't do that until we get rid of the power, but we can't get rid of that until we get rid of the 250. It's like peeling back the layers of an onion. Okay, so I'm going to divide both sides by 250. If you divide 610 by 250, you get 2.44. Okay, so I'm just going to go ahead and write 2.44 is equal to 1 plus R to the 4th. Now, I will admit I didn't show my work the way I normally do, but I'm going to assume everyone understands the way I got from here to here was I divided everything by 250. If that confuses anybody or you want me to show the work, just speak up. Okay, I don't mind showing that. How about my next step? Somebody other than Davian, how do we move forward at this point? I heard something about a root. Which root should we use? Because we should not use the square root, not the 4th root. We have a 4th power, so we should be taking the 4th root of both sides. Okay, that is what will get the 1 plus R part by itself. So I need to know what is the 4th root of 2.44. So I go to my calculator, and I type the 4th root of 2.44. Now, when I hit enter, again, we're going to get some crazy decimal, but I always take 3 decimal places. So I'm going to take 1.249. This one's going to round a little weird because the 9 is followed by an 8. So the 9 should round up to a 10, but you can't put a 10 in one spot. So when the 9 gets pushed up to a 10, what that really means is the 4 gets pushed up to a 5. Does that make sense? So when I round this to the 3rd decimal, what it ends up being is 1.250. Of course, I'm not going to bother with the 0. I'll just write 1.25. So I now know that 1.25 is equal to 1 plus R. Now our goal again is to figure out R, so what do I still need to do to both sides? I appreciate it, but I'm hoping to hear from somebody else. I've got 1 plus R, folks. How do you get rid of a plus 1? You subtract 1. It's the opposite of adding. So what I'm going to do is subtract 1 from both sides, and that gets me 0.25 is equal to R. That is the answer to part A. Okay, so apparently this bacteria is growing at a rate of 25%. Remember, I've said multiple times, the first 2 decimals are your percentage location. So if it's 0.25, it means 25%. Now, you can always check your work. That's one of the beautiful things about mathematics. We're claiming that if you have bacteria go from 250 to 610 in 4 hours, the growth rate was 25%. Well, test it. Go to your calculator and say, all right, if I start at 250 and I have a growth rate of 25% and I grow for 4 hours, is this going to get me 610? Okay, and if it is, well, then you can be confident that the rate you got was accurate. Now, I want to remind you, the 0.25 was based off of a slightly rounded number. Okay, it wasn't 1.25, it was 1.2498 something, 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 something. So when I hit enter, I don't expect to get exactly 610, but I get something that's really close. So this is a way of confirming that the 25% is good. Okay. Now, part B says write a model to represent the number of bacteria in terms of T in hours. So anytime you're asked to just write the model in general, you're not being asked to calculate anything. That'll be the next part. The next question says use your model to calculate the number of bacteria after 9 hours. That's a separate issue. But when you're asked to just provide the model, the A and the T should be part of your work, because the whole idea is you're trying to design a model that will allow you to calculate the final amount of bacteria based on the time in hours. And the only two things you need to be able to write this formula is how many bacteria did you have in the beginning and what is your rate of change, which in this case is a growth of 25%. I say growth because we're adding. Okay. Now, for the last couple of days, I haven't really demanded much of you all to work ahead of me as much as I normally do. I want to pause here and give you a chance to work ahead of me. So take 3 minutes and see if you can complete both parts C and D, where you're simply using this equation to plug in values for T and solve for A. Take 3 minutes, folks, to work ahead of me. Go. All right, so I gave students 3 minutes ahead of me. With part C, you're just taking your equation, but plugging in 9 for T. Okay, and in this particular case, you get a little over 1,800. And by the way, I have no problem whatsoever if you want to round that to 1863, because there's certainly an argument for you can't have a fraction of a bacteria. So if your instinct is, let me round this to a whole number, I totally agree with you. That's no problem. Now, can anyone tell me what number would you need to plug in to do part D? Because you definitely should not plug in 9. That was part C. But what number would you plug in for D? Yes. Not 2. If we were measuring time in days, you would plug in 2. 24 would be right if we wanted to know the number of bacteria to expect in a single day. I appreciate the attempt. You're on the right track. 48. So it's 2 days, and each day has 24 hours. So it's 24 plus 24. The number you should be plugging in for this next one is 48. And let me warn you now, if you haven't already done this yourselves, if you've got something that grows at a rate of 25% an hour, 48 hours later, this is going to exponential its way through to the moon. 250 bacteria is going to grow to be over 11 million. Okay, this, by the way, is one of the reasons why I've said there's no bank out there that would ever offer in a savings account 25%. There's no investment portfolio that has consistently earned 25% for 48 years running. You know, my own retirement account has averaged around 8.5%. If you actively manage your stuff, you can probably get around 10%. But if anyone claimed that they can average 25% year after year after year after year, I would suspect that they're doing something shady. Okay. And what this is really showing, by the way, if there was somebody out there that by some sheer genius effort, they were able to average 25%, what that means is they could put $250 in an account and 48 years later, it'll grow to over $11 million. Don't think that's happening. Okay. That's an insane growth rate. But bacteria can certainly do that. All right. Questions before we turn the page? All right, before we go ahead and turn to the next page, but before I go through it, I just want to reiterate, this is something I said at the beginning of the period. This page is a very, very good indication of what you should expect on your CFU this Thursday, with one exception. On the CFU, I am not going to give you this helpful starting question where you have to sort of list out what do you know, what don't you know. Okay, I'm just going to go right into write the equation, use the equation. Okay, just to warn you. So the practice that we're doing in class is giving you a little bit extra of a helping hand. Okay. So up at the top says, as you solve each problem, be sure to define your variables and show your work. In 2000, Maryland's population was approximately 5.3 million people. Beginning in 2000, Maryland's population grew by an average of 0.9%. That's our rate. We're going to use this formula to model the Maryland population based on year. Now, they didn't tell us how long we're going to be modeling it. They didn't tell us the final population after a certain number of years. What they gave us was the initial value and the rate. I have purposely not shown you the rate yet. I'm curious, does anyone know what would 0.9% be as a decimal? Yep. Ooh, super close. Okay. So if he had said 0.9, I would have said, no, unfortunately, that's like 90%. Because remember, the first two decimals say percentage. What he said was 0.09, which is closer, but even that is 9%. As a helpful boost, this is 1%. We don't even want a whole percentage. We want a piece of a percentage. We want 0.9%. Davian, I saw your hand up. What is 0.9% as a decimal? Unless you had a question. Do you know the decimal value? So 0.9 is the first answer I have on the screen. So it turns out, go ahead. Perfect. You just needed one extra zero. That is 0.9%. Now, in case you're unconvinced, let me remind you of a math trick to convert from percentage to decimals. Okay. If I wanted 90%, then all I have to do to convert that to a decimal is divide it by 100. 0.9 is 90%. If I told you I wanted 9%, well, just divide it by 100 and you'll get 0.09. That is 9% as a decimal. But in this particular case, we said we wanted 0.9%. If you want to convert a percentage to a decimal, you divide by 100. And that's where the 0.009 comes from. So that is the value that should be here. And as I said on the previous problem, if you're being asked to, like in part B, write an exponential model, okay, you should not be putting numbers in for A and T. The whole idea is you're trying to write an equation that predicts the final amount based on a certain amount of time. So A and T should not be numbers. They should literally be letters. And the only two pieces of information you need to write an equation is what is your starting value, in this case, 5.3 million, and what is your rate of change, which in this case is a growth of 0.9%. Again, I stress the word growth because that's why we're adding, plus 0.009. Now, if that's all you can do, if all you can do is read a paragraph and write out a formula, that is enough to get nearly half the points on the CFU on Thursday. Because it's going to be two problems kind of like this. And with each problem, it's going to be write in a model, bless you, then solve for a value, find a population. Okay, and that's what we're going to do next. It says, use your formula to determine the population in Maryland in 2011. So they're giving you time. But I'm going to tell you right now, do not plug in 2011. That's going to be 2011 years later is what you're calculating. The population is going to be to the moon. Okay. If we're calculating a population in 2011, can anyone tell me what we should use for T? How many years later is that? Say it again. 11. Perfect. The problem says in 2000, the population was 5.3 million. So we're starting in 2000, and now we're being asked to make a prediction in the year 2011. So you have to be able to realize what that means is plug 11 in for T. Okay. So this is going to be another situation, by the way, where if you rounded to a whole number, I have no problem with that. So I provided the exact value to 3 decimals, but if you rounded this to 5,848,961 because it's a 0.6, so you round it up, I have no issue with that. That makes sense to me. Questions? All right, now normally what I might do is say, all right, take some time, work ahead of me on this next problem. But like I said, I'm trying to get you all some time on your homework, so I'm going to go right into it. It says Ned opens a savings account that has an interest rate of 2.25%. Now, again, if you want to convert a percentage like 2.25 to a decimal, all you do is divide by 100. Okay, and I would argue what's about to appear on the screen hopefully would make perfect sense, because I keep saying over and over again, the first two decimal places is your percentage. So if I cover up the 2 and the 5 for a moment, we just look at the first two decimals, 0.02, that means 2%. Any numbers that come after that are a piece of a percentage, which in this case is 0.25. So 2.25% as a decimal is 0.0225. Now, they told us the initial investment was $1,500. They didn't say anything about how long the money was in the account. They didn't say anything about how much money was in the account after a certain period of time. They just gave you the initial amount. They just gave you the interest rate. But those two numbers are all you need to be able to write an equation. Because if you want to calculate the final amount, all you need to know is what was the initial amount and what is the rate of change. Okay, don't forget about the variable t, because in the end, you want to plug in a value for t to calculate, well, what's the value of the account after a certain amount of time. And the very next question gives you that. The very next question says, according to your model, how much would be in Ned's account after 3 years? So all we're doing is taking our model and plugging in the number 3 for t. Don't expect this to be anything amazing. 2.25% is a very small percentage. 3 years is not a very long time. So if I had to guess, maybe you're going to earn, I don't know, like $100, might be up to like 1,600 or something like that. All right. And you get 1,603 with 55 cents. Questions? So even though this is a shortened period because of advisory schedule today, we still have 12 minutes until the official end of the period. I would recommend you use that time to work on homework 26, or if you didn't do homework 25 yesterday, use the time to work on 25. But next week on Tuesday, I'm collecting all 5 homework assignments from this week, 25, 26, 27, 28, 29. Okay? Anyone watching the video? Thanks for watching. Have a good one.